Hi, I am Shah. Welcome to Shah TechTuber. Today we will learn about computer architecture and try to know about the process of computer architecture and its types. Computer architecture refers to the design and organization of a computer system, including its hardware components and how they interact to perform various tasks. It serves as the foundation for the construction and operation of computers. At a high level, computer architecture can be divided into two main components: the central processing unit, CPU, and the memory system. The CPU is responsible for executing instructions and performing calculations, while the memory system stores data and instructions that the CPU needs to access. Here are some key concepts and components of computer architecture for better understanding. First, we try to understand about CPU. CPU, Central Processing Unit. The CPU is often referred to as the brain of the computer. It carries out instructions by performing arithmetic, logical, control, and input-output (I/O) operations. The CPU consists of several subcomponents, including the control unit, CU, and the arithmetic logic unit, ALU. Second, we try to understand about random access memory. Memory is divided into different levels, each with varying speeds and capacities. The primary types of memory are main memory, RAM. This is the main working memory of a computer, where data and instructions are temporarily stored during program execution. Third, we try to understand about cache and secondary storage. Cache is a small, high-speed memory that stores frequently used data and instructions, allowing for faster access by the CPU. Secondary storage. This includes devices like hard disk drives, HDDs, and solid-state drives, SSDs, which provide long-term storage for programs and data. Fourth, we try to understand about input and output. Input-output I/O. These are the components that enable communication between the computer and external devices, such as keyboards, mic, monitors, printers, and network interfaces. The I/O system transfers data between the computer and these devices. Output devices display or transmit processed information from the computer. Examples include monitors, printers, speakers, and network interfaces. Output devices convert digital signals from the computer into human-readable or machine-readable forms. Fifth, we try to understand about bus. Bus is a communication pathway that allows data and instructions to be transferred between different components of a computer, such as the CPU, memory, and I/O devices. It acts as a shared medium for data exchange. Six, we try to understand about instruction set architecture, ISA. Instruction set architecture, ISA. ISA defines the set of instructions that a CPU can execute, as well as the programming model and the registers available for use. It serves as an interface between the hardware and software, enabling software developers to write programs that can run on different computer systems. 7, we try to understand about pipelining. Pipelining is a technique used to improve CPU performance by allowing multiple instructions to be executed concurrently. It divides the execution of instructions into a series of stages, with each stage performing a specific operation on different instructions. 8, we try to understand about registers. Registers are small, high-speed memory units located within the CPU. They store data and instructions that the CPU needs to access quickly during its operations. Registers include the program counter, PC, which holds the memory address of the next instruction to fetch, and general-purpose registers for temporary data storage. 9th, we try to understand about parallelism. Parallelism involves performing multiple tasks simultaneously to increase overall computational speed. It can be achieved through techniques such as multi-core processors, where multiple CPU cores work together to execute instructions. 10th, we try to understand about von Neumann architecture. Von Neumann architecture. This is a classical computer architecture model that consists of a CPU, memory, and I/O devices. It emphasizes the stored program concept, where both data and instructions are stored in memory, and the CPU fetches and executes instructions sequentially. 11th, we try to understand about RISC and CISC. RISC and CISC. These are two different instruction set architectures. RISC, Reduced Instruction Set Computer, focuses on simpler instructions that can be executed quickly, while CISC, Complex Instruction Set Computer, includes more complex instructions that can perform more powerful operations. 12th, we try to understand about I/O interfaces. 12th, we try to understand about I/O interfaces. I/O interfaces facilitate communication between the CPU and external devices such as keyboards, mic, monitors, printers, and network interfaces. These interfaces provide the necessary protocols and hardware for data transfer between the computer and the devices. Thanks for watching my video. If you like my video, please subscribe.